Good afternoon. Thank you so much for joining us. We're proud to present our next speaker, Daniel Mintz with Looker. Please give him a warm welcome.
Her. I'm going to keep her. I'm going to bring her everywhere that I speak. Thanks for joining us. I'm going to be talking about Looker. Looker is a data analytics platform. It helps people get more value from their data. If you're somebody that uses Redshift or RDS, has data that you probably have people who want to ask questions of that data, Looker's a really good tool for doing that. It actually leverages all of the power of Athena, of Redshift Spectrum, of RDS, of Aurora, whatever relational database you're using. If you want to be able to ask questions of that data, get those answers in the hands of the people who are making decisions in your business, Looker is really great at that. But you can also sort of flip things around, and I'm going to talk a little bit about that because AWS, part of using the AWS cloud is that they give you a ton of data about how your cloud is doing. And sometimes that data is not the easiest to make sense of or to make good use of. And so if you're somebody in DevOps or a database administrator trying to get value from that data, Looker can actually be a really great tool for that as well. So I'm going to talk about sort of both those use cases. And we'll just speed through this because we've only got 20 minutes, so we're going to go fast. But we're mostly going to be talking about getting more from your cloud and Looker's AWS optimization suite, which is one of the tools for doing that. So I assume everybody here uses AWS already. Is that a bad assumption? Raise your hand if you don't already use AWS in some capacity. You're fired. Get out. He works with me. It's OK. So the reason that you probably are using AWS to do some stuff is because it strikes the right balance, right? The balance that you're looking for, which is it gives you all of the knobs and dials that you probably want to twiddle to get all of the great performance out of it, but it's really simple, right? And so it doesn't make you stand everything up on your own. They take care of a lot of those complex IT tasks. They sit right in that middle spot, and that's really nice. That's what the market wants. That's why AWS is used by so many companies. But AWS is such a huge ecosystem. Feel free to come on in. I feel like a carnival barker a little bit. Come on in, come on, come on. They give you so much stuff. The ecosystem is so large. There's so much going on. I don't think anybody knows all of the things that are available to them. And so there's always an opportunity to get more out of your implementation. So as somebody who might use an AWS database or a data warehouse or a data lake or a data engine or, I don't know, a data anything, you might be struggling to answer some of these questions. You might be trying to understand how your data is structured or how up-to-date it is. You might want to know from a user's perspective, does it feel fast? Are queries coming back quickly, right? Do I need to increase the size of my Redshift cluster? How much am I spending on this, right? Is this something that is really living up to its value, or am I paying too much, or should I sink more money into it? And then on the security side, if you're a DevOps person, well, what errors are we seeing? How often are we seeing them? Where are they most often popping up, right? Or you might be experiencing some of these pain points. If you're using Redshift, and I've used Redshift for a long time, since basically it became a public tool in 2013, it's often hard to know exactly which knobs and dials to twiddle in Redshift, right? If you twiddle them just right, you can get extraordinary performance out of Redshift, but knowing exactly how to do that is often pretty complex. You might want to know, which tables are getting queried most. Maybe I want to change the distribution strategy on those tables, but actually understanding that at a company-wide level, who's using which tables is pretty hard. You might have put aside a certain budget, gotten approval for that budget, and then realized that the performance wasn't what you were hoping for, or you had to increase that budget, right? So you want to know, why aren't the costs matching up to my expectations? And then just in general, you might want more visibility into what exactly is happening inside the cloud, right? The cloud is this really big, nebulous thing, and so really understanding what's going on up there can be tricky. So Looker looked at this problem and said, well, the nice part is that Amazon gives you a ton of data about what is happening in your AWS cloud. The not so nice part is that making sense of that data is not always that easy, right? So there's a ton of power there, but you're not always able to leverage it very easily. And so what Looker did was we have this concept called Looker blocks. And blocks are basically, we hear from our customers, hey, I'm trying to solve this problem. Has anybody ever run up against this problem before, right? And often those are things like, hey, I have Salesforce data, and I want to make sense of it for my sales users. Well, guess what? You're probably not the first person that's tried to make sense of Salesforce data. So we actually took our knowledge, took all of those sort of best practices that we learned from our customers, and built those into a ready-made block, something that you could just install, that's just code ready to go, but it's not a black box, right? So it gets you 90% of the way there, but then for Salesforce, we know, well, every single Salesforce implementation differs. They have different custom tables, different custom fields, and you want to be able to do that customization so you can actually understand your data, because otherwise you get into that weird meeting where finance says, well, this number's like 10 times too high on my dashboard. Why is that? And you go, well, I don't know. What did you do? And they go, oh, well, you're counting all of the canceled returned items. That's the problem, right? That's always a fun meeting. When they're like, you didn't realize that we didn't make $100 trillion last year, and you're like, yeah, probably that should have tipped me off that something was wrong. So we've done that with things like Salesforce, but we've also done it with AWS, right? AWS gives you all of this very nicely structured data about what's happening in Redshift, what's happening in CloudWatch that you can make sense of, but you probably don't want to do that on the console. It'd be nice to have a dashboard, right? To have some pre-built stuff that knows how that data is structured and how to make sense of it. And so that's what the AWS optimization suite that we offer is. And so there are 4 components here, four blocks, and all of them put together allow you to leverage all of this data that AWS is giving you for free. If you are not getting value out of this data, you are leaving something that they are giving you for free on the floor. It does this using SQL, right? So the data that AWS is giving you is landing in an S3 bucket somewhere, or can be downloaded, or often is actually in Redshift itself. And so the way to get at that is with SQL. You're getting industry best practices. We develop these blocks with AWS engineers, with the folks who are building Redshift, who are building Athena. So we have all of the best understanding of exactly how to use this stuff well at our fingertips. And then, obviously, you're going to be able to sort of reduce your cost to improve your performance, and you're going to do it from one place rather than having to jump to 10 different tools. So the 4 blocks that comprise the AWS optimization suite, one is all about administering Redshift. Right? So what are the ETL patterns that are pumping data into Redshift? How often are they running? How long are they taking? How are my tables architected? Right? Are they distributed well? Is there weird skew that I should know about? Maybe I want to set up an alert so that I get alerted if something skews more than X%. There's another one on AWS cost and usage, right? So how much are we using stuff? Are there places we could save money by reserving instances? The third is Redshift optimization, so that's down at the query level. How many people have ever looked at a SQL explain output? All right, we've got 4 people. What are the rest of you people doing here? I thought everybody was a nerd here. I thought it was like 50,000 nerds who love explain statements. So explain statements are amazing. They tell you exactly what the SQL engine is thinking, and they're also horrible. I'll show you what I mean in a second. But this allows you to look at a particular query and actually understand, not just have it explained to you and then look at it and go, I don't know what that means, but actually understand what is the query doing, why is it taking as long as it did, is there a way to optimize it? And then finally, for security and monitoring, I like that everyone was waiting for all 4 so they could take the picture. That's good. That's smart. You folks are with it. I like that. So you can monitor error monitoring. You can monitor security groups, logins. You can see when access controls changed, when your IAM settings changed, things like that, right? So you can see all this in one place. So the Redshift admin block, it's really going to break down those ETL processes so you can see when were tables loaded, what do those summaries look like, what files have been loaded, what errored. Even just in Redshift, one of the things that's often tricky is knowing, well, when did an ETL process fail, right? And why? What was the error message? This makes that really simple. It also gives you a snapshot of what's already in your database so you can see that and understand how well it's performing. The Redshift optimization block is going to show you those network activity patterns, those like DS distribute type. For anybody who has looked at those explain statements, you'll know what I'm talking about. For everyone else, just be glad that you've never seen these things. But the network activity where Redshift is shuttling data between nodes. It also, you could set up an alert and say, hey, I want to know if my nodes get to 85% capacity, right? I don't want to run out of file space on my nodes. I want to have time to increase capacity before then. It also give you the ability to look at query time and inspect those queries. On the cost and usage side, you can break down, you can sort of slice and dice that usage so you can understand, I want to look at it by reserved instances versus unreserved instances, spot instances. I want to look at which products are costing me how much. And then you can also look at reserving resources for the future and make those calculations to see how much you would save. And then finally, on the security and monitoring, you're really getting deep into that operational activity, getting a sort of console login overview so you can see who's doing what, makes it really easy to do auditing of how people are using your AWS cloud. So now I'm going to switch over and actually show you what this looks like rather than just showing you slides. So let's go to the demo. There we go. So just for folks who aren't at all familiar with Looker, so Looker is a business intelligence tool. It's a data analytics platform. This probably looks like other things that you have seen. The big difference, though, so Looker actually is built to leverage really fast, powerful databases like Redshift, like Athena. Most BI tools were built in a world of really slow, expensive databases, so they had to make sort of adjustments for that, right? That was kind of how they were built to work. Makes sense. But the world today is a very different world where you can spin up a Redshift instance in minutes, start loading data in, throw Looker on top, and start querying it immediately. So Looker is sitting directly on top, writing SQL, sending that SQL off to your database so that you're not keeping your data in two places and paying to query it twice, leveraging all of that power, and then letting you see the results in your web browser. So if you want to look at this, you've got, here's our brand analytics, web and transactional data. Maybe I want to drill in and understand who these 76 Linux users are who are looking at it. I can drill down to row-level detail because I'm right on top of the database. I'm not working on extracts. I'm working on the whole data set and letting Redshift do the work. So let's look at the Redshift performance block. So this is the one that's showing you the sort of top-level overview of what Redshift is up to, how things are going. There's that network distribution breakdown that I was talking about, those broadcast inner, broadcast outer. And so we can look at this, and here's a really simple but really powerful visualization, which is just a histogram of how long are queries taking. Are there queries that I should be worried about that probably feel really slow to my users, right? And so maybe I want to drill in and understand, well, OK, it looks like there were 4 queries that took between 10 and 15 seconds. That's probably slow enough that for an end user that feels slow. So let me drill in, assuming that the Wi-Fi blesses me, and see these 4 queries. So here are the 4 queries that were taking that long and exactly how long they're taking. And one way, I will show you the sort of standard, old school, normal way to sort of dig into this query performance, right? So let's look at that last one, query number 611057. Now, I'm going to jump over to my SQL runner. You probably all are familiar with this. I'm going to go to the very popular STL query table in the Redshift admin. And I'm going to type in that query number. I'm going to run this so that I can get all the details about what was going on with that query. And there's that really beautiful query text. So let me grab all this. If this feels familiar and I am causing you PTSD, I very much apologize. So now let me paste the query text in. Let's find the beginning. All right, select. We'll replace that with an explain. There we go. And now easy peasy. We've got our problem solved, right? We can figure out exactly from this explain why exactly this is taking 13 seconds. Yeah, probably not, right? Like, OK, now Redshift is telling us exactly what's happening with this query and why it's not going as fast as we want. But unless you're a very strange person who delights in reading explains, this probably doesn't mean much to you, right? So I'm here to tell you there is a better way. So the alternative would be to go back to this Redshift performance block and say, you know what, actually, I'd like to inspect this query and see exactly what is happening. So let's do that. We're going to jump over to that other Redshift optimization block. It's going to auto-fill in the query name. And aha, now, yes, we can see the query text, but we can see a whole lot more about what is happening with this query and why it's not doing what we wanted, right? So it's not a sort problem. That's good. It's not a disk problem, which is often one of the things that makes Redshift really slow when it has to write stuff to disk and pull it out of memory. It looks like we're scanning a bunch. We could actually walk through the query execution. This is really, I'm feeling very nerdy doing this on stage, but it's OK. I feel like you're a receptive audience. So we can walk through this query execution. We can see how many rows, how many bytes are being scanned from each of the tables that's involved in the query, right? This is a much user-friendlier way to actually understand what's going on, right? And this is just one of the many ways that this Redshift optimization suite, that the Amazon optimization suite gives you to actually understand what's going on, right? So as somebody who is working on that back end, you're probably used to making do with pretty substandard tools, right? With the tools that look like a SQL runner or console. And what I'm telling you is you don't have to do that. There's a better way. And in the same way that you're probably trying to serve your business users with something that's a little user-friendlier than this, there is the same thing available to you as somebody who's working in the database. And so whether what you're doing is Redshift query inspection, like this, or drilling in and trying to understand, why do we have all of these undefined lifetime purchase values here? Why do we have these trends? Because you're a sales manager, Looker can provide both of those things. And the reasons are the same, which is that it's all just data, right? And so the key thing is to be able to make sense of that data, because nobody wants data. Data is worthless. People want information and they want knowledge about what's happening inside their business, whether that's optimizing a database, whether it's monitoring security logs, or whether it's optimizing sales and warehouse distribution. And so what Looker does, what Looker really excels at, is taking that raw data that lives in RDS, lives in Athena, lives in Redshift, and getting it into normal humans' hands where they can make sense of it, where they can actually make better decisions with it. And so, because I've got 3 minutes left, I'm going to show you the secret sauce of how we're actually doing this, which is this thing called LookML, which is pretty nerdy, but I feel like you guys will like it. And so let's look at, I don't know, let's pick one. Let's do this. And so what LookML is basically just an improvement on SQL, where SQL is great. I adore SQL. I love it. It thinks the way that I do, but it really sucks in a bunch of ways. It's not reusable. If I look at a query that I wrote more than 2 minutes ago, I can't make sense of it, or I'm like, why did I do that thing 2 weeks ago? And so I end up rewriting the SQL query from scratch. That's really, really inefficient. Software developers would never stand for that. They figured out ways to modularize their logic so that it can be combined and recombined and recombined in ways that saves them time. That's what LookML is, right? So it's all the power of SQL, but in a way that can be recombined so that I can say, well, here is this field that I want to be able to use, that's called git repo, and it just lives in my table. But I also want to be able to link that out so that I can link directly to the GitHub repo, right? I don't want to look at it in a SQL runner. I want to be able to link out to it. Or I want to be able to combine things for lifetime customer value. And I need to pull data from a bunch of different places. But I don't want to have to rewrite that field every time that I need to see lifetime customer value or slice it a different way. I want to be able to just click a button, have the software know what the meaning of lifetime customer value is, what that means to my business, and write the correct SQL. And that's what Looker does. So by not moving your data, by leaving it where it lives, whether that data is metadata about how Redshift is performing or it's your sales data, it gives you an interface where you don't have to worry about the low-level details of how those things are defined, but you can instead focus on the high-level things like, how do we do our jobs better? How do we improve Redshift performance? How do we make better sales decisions? So that's basically Looker in a 19-minute nutshell. We are over sort of by Cognizant if you want to see a fuller scale demo. We're in booth 1201, and we're also actually now partnering with AWS to offer a free trial of Redshift and Looker together, so that you can try this stuff out. One of the really nice things about these fast, cheap databases is you don't have to spend $1 million up front. You can spend pennies, or in this case, not even pennies, to try it out. Throw some scratch data in, put it in Redshift. It will blow your hair back if you haven't used it already. Put Looker on top, put some dashboards in front of users, and be happy. I'll stick around for questions, but thanks, everybody. Thanks very much.